An elevator being lowered into a mine shaft starts from rest. Starts from rest means t is equal to 0, v is equal to 0, and attains a speed of 10 meters per second with a distance of 15 meters. The elevator alone has a mass of 500 kg and it carries a box of mass 600 kg in it. Find the total tension in the cables supporting the elevator. You can see those cables as one single cable there. Okay. During the accelerated motion, also find the total pressure between the box and the floor of the elevator. Now, although they have said total pressure, since we don't know the dimensions of the box, we can just say that we need to find the force. Okay. Now, first of all, let us try to find out the acceleration of the entire block, entire lift. Okay. So this is lift including the box. So its weight will obviously act downwards, which will be 1100 into 9.8. Wait. Now, in which direction will the tension act? Upwards.
Reaction to tension.
There is no reaction. It is moving downwards. Okay. And the lift is moving downwards. So we should also show the force like this. That is the mass into acceleration. Correct? Please note that in this we should consider mass of the entire system. So that has to be 1100. Mass of the box as well as mass of the elevator. So if we apply the Newton's second law to this particular object, which is summation F is equal to ma, what will we get? In this case, T has to be negative because the lift is moving downwards. So 1100 into 9.81 minus T is equal to 1100 into the acceleration. See, wait, we still don't know the acceleration of the lift. Can we find it from the data given here? Yes. We can say that v squared is equal to u squared plus. But before using this equation, we should make an assumption that acceleration is uniform. Although they have not said anything about it. Only then we can use this. If acceleration becomes variable, then you can't actually use this. Okay. Now what is v squared? V squared will be 100 because this is 10. So 100 is equal to 0, 2 into acceleration, which is positive in this case, and the distance traveled is 15. This implies that acceleration has to be equal to 100 divided by 30. How 1 by 3? 10 by 3? Yes, 10 by 3 or 3.33. Yes. Now we will substitute this value in this equation and get T. So T will be equal to 1100 into bracket 9.81 minus 10 upon 3. Correct? Take this term on the left hand side. T will go on that side and will become positive. And then take 1100 common. So 9.81 minus 10 upon 3. So 1100 into bracket 9.81 minus 10 by 3, that is 7124.33. Okay, so we have found out the first unknown, that is tension. Next, also find that during the accelerated motion, also find the total pressure between the box and the floor of the elevator. See, now if you consider the free body diagram of box, it will be different from the free body diagram of the entire elevator or lift. since the cable is not in direct contact with the box, we can't show tension there, but we have to show the normal reaction. Okay. And weight. But now we will consider 600. Very good. 600 into 9.81. But acceleration is still same, which is 10 by 3. Okay, so this is moving downwards with an acceleration of 10 by 3. So if we just multiply this by the weight of the box, it will be 6. Okay, now apply the Newton's second law of motion, which is summation F is equal to ma. Now what is summation F? It is 600 into 9.81 minus R, the normal reaction, equal to 600 into 10 by 3. Therefore, R is equal to 600 into 9.81 minus 600 into 10 by 3. So 600 into bracket 9.81 minus 10 upon 3, 3886. So the normal reaction offered by the surface is 3886 newtons. I mean, you might have experienced this in lift. If you are moving down, you appear to be lighter. And note that this weight 3886, this is the apparent weight 3886 newtons, and your actual weight is 600 into 9.81, and the difference in this is because the lift is accelerated. Okay, because once the lift starts moving, then you don't feel the reduced weight. Only when it starts or stops you feel that. Okay, so that is normal reaction. And had we known the surface area of our feet, not our feet, surface area of the box, I would say the bottom cross surface area, then we would have said that the pressure would be 3886 divided by the surface area, pascals, because pressure is always measured in pascals. Let's check if we want to find anything else. Find the total tension, which we did. Find the total pressure, which we did. Okay.